Okay, let's have a look at question 2. So we're looking at how the stopping distance of a car depends on its speed. Part A says state how the stopping distance changes with the speed of the car. So let's compare two different speeds. So at a speed of 20 meters per second, the stopping distance is just under 50 meters. While if we increase the speed to 40, the stopping distance also increases to 120 meters. So we can say that if the speed increases, the stopping distance also increases. Then for part B, use the graph to estimate the stopping distance for a speed of 45 meters per second. So we need to look at 45 on our graph, which is up here, and we need to go across until we hit a line, and then down, and we find that we've got a distance of 140 meters. Okay, if we go down to part C, when the weather conditions are poor, the stopping distance change. Add another line to the graph to show how the stopping distance may vary with speed if the road conditions are very wet. So if we look back up, if the road conditions are very wet, then the stopping distance will be larger. Okay, now that's going to look like a curve that's below the one that we've drawn. Okay, it should have a similar shape though. Okay, the reason it's below is that if we pick a particular speed, for example 10 here, our line needs a bigger stopping distance than the original line. Okay, right, the final one, says explain why the stopping distance of a car travelling uphill is less than when it's travelling on a level road. Well, what we're looking for is that the weight of the car is an additional force that acts against the motion. Okay, so we'll say that the weight acts against the forward motion of the car.